Well, hello there. This is Dr. Dell, and this is going to be a video about the interlude that you've come to in your reading of my book, Teaching Math. Of course, I'm Craig Hain, and my students call me Dr. Dell, and I'm with TriadMathInc.com if you want to know more about this from a website. And in this book, Teaching Math, as you know, we've come to an interlude, and that's what I promised to talk to you about on this video. Now, the interlude is a triangle problem that I alluded to that we teach our students at a certain point in our foundation program. And I want to talk to you a little bit about that today, what it is and why we do it. I assume you have read the interlude, so I'm not going to reread it for you. But the bottom line of it is, of course, is that we challenged you with a triangle that we had the measure of two sides and we knew their included angle, and the question is, what is the area? Now, I'd like to tell you how we treat this in our course and why. This is the foundation course that we're talking about here, and it consists of all of the things you need to know from algebra and geometry and trig to do practical math problems. And it's about a 40-hour program for most students to take. It's online videos, as you know, and this is the workbook then, or the notebook that goes with the videos. And we start out by teaching, of course, the students how to use a calculator. So that's a very important feature of this whole thing. We use the TI 30XA calculator, which is about a $10 calculator, and it's a very, very good one. I checked out lots of different calculators and decided this was the best for our purposes. And in fact, it's the one I use all the time if I'm out in the real world doing practical math. Okay, so the first thing is we have a series of lessons on that. Then we do some pre-algebra, which is like arithmetic review. This is considered post-elementary, but we want to make sure everybody is up to speed before we dive into the high school level math, which is the algebra, geometry, and trig. And of course, there are for each lesson there is a page here. Now, I'm going to show you a table of contents here about what is in the program so you'll see where this fits. This is the first set of lessons, or 16 of them, on how to use the calculator. And they're all very short, and they all focus on a specific key in the calculator that you're going to be using in this course. And so most students get through this in a few hours. And when they get done, they have a comfort level with the calculator, and they know how to fix the decimal point, for example. If you take the inverse of 7 and you want to fix it to 2 decimal points, then they learn how to do that. They learn how to use the fraction keys and a whole lot of other things that you need to know. Then in the pre-algebra, we're basically doing a arithmetic review of how addition and multiplication and what squares and square roots are and things like that. And again, using the calculator, emphasizing its use always to do all of the drudgery work of the calculations. Then after pre-algebra, we have a set of lessons on algebra. Now, this is the algebra that you need for practical everyday math. And each one of these is a lesson, A1, A2, down through A10. We have some optional lessons that you don't need in the foundation, so we focus on these 10. And each one of these then is a video lesson from a page in the notebook. And then after the lesson, there is a problem set in the exercise notebook I'll show you in a moment. And then after that, there's an online quiz to verify that they've learned it. This is all part of meeting the criteria of the effective math education triad, which you have learned about already in the book Teaching Math. Then we have geometry after algebra. And where the problem I've alluded to today comes is in G8, area of triangles. Now, we've already talked about parallel lines and right triangles and similar triangles, which, by the way, I point out in geometry is one of the most important topics because it really begins to let you combine algebra and geometry, which is what you typically do. And then, of course, the last section is on trigonometry, which, of course, we will not come to until after geometry. As I said, the whole program takes about 40 hours of student time for most students. And so today I want to talk about in this interlude about how we've dealt with the idea of area of a rectangle even in geometry. So here we are in geometry, and I point out that if you have we start with a parallelogram, which is kind of like a lopsided rectangle. And the formula for the area of the rectangle is just A times B, the length of the width of the rectangle. But if you have a parallelogram where it's like a rectangle but it's lopsided with an angle X degrees in here, then that formula AB will not work unless you apply a correction factor, is what we call it. And the correction factor is simply the sine of that angle. So the students then learn with a series of problems how to compute that area for a parallelogram. And then, of course, for a triangle, it's the same thing, except you have to now multiply by 0.5 because a triangle is half of the parallelogram. And so that is what we do, and that's what I wanted to tell you in the interlude. The correction factor that I alluded to is nothing more than the sine of that angle. And so in this case, the angle was 49 degrees, so the student actually learns to take 49 and to take the sine of it, and that's the 0.755. I'll fix that to 3 decimal places, and that's what I told you was the correction factor. Now, why do we do it this way? Why don't we wait until we get to trigonometry? There's a couple of reasons for that. We want the student to understand, and we emphasize throughout this, that what problems you're able to solve depends on what tools you understand and have available to you. And in geometry, there's a lot of things you can solve for the common angles of 30, 45, and 60 degrees. But when you get angles that are not the standard common angles, then you have a problem, and you don't have enough information from geometry and algebra really to solve this problem. In fact, this problem cannot easily be solved using geometry and algebra. It can be done, but it's difficult. It's much easier with then trigonometry, and that's what we're getting ready for. So the student is introduced to the sine function as a correction factor. Now, we don't stop at this point in time and define the sine and explain what it is. That'll come later in trigonometry. And once they get to trig, then they will indeed understand why that correction factor really works. That in point of fact, what really happens then is the correction factor, the sine of theta, times A, is really then the height of the line that would be dropped to the side B. And they learn that in trigonometry, but we don't tell them that right now. And I find this to be very effective when you're teaching students. You always want to be peeking ahead and getting them anticipating what's coming. So we often will show them a problem that would be interesting to solve that they're not ready to solve. And this would be an example of that until we tell them the correction factor. There's some other triangle problems, of course, that you can't solve even at this point, and we give them some of those sometimes and show and challenge them to try to solve them, which of course they can't. They don't have the tools. And we'll talk about a couple of examples in the next 2 interludes. We have an exercise book that goes with each one of these lessons, and so I marked it here in advance to find it easily. That was lesson G8 for Geometry 8, and this is the exercises that we give the student to work. And then we also, of course, give the student the answers to these exercises on the next page so that they're encouraged every time they take a lesson to then do problems, because as we tell them repeatedly, math is a contact sport. You have to do it to learn it and to understand it and to master it. And so we give them problems. And we would recommend that you as a teacher give them additional problems if you care to do so. And if the students want them, there's no limit to how many problems that a student can do until they feel they've mastered it. But we give them what we think is usually adequate for most students to master the particular topic in hand. And of course, the exercises are very related exactly to what we've talked about in that video and in that lesson in their notebook. So this exercise book is a companion book to the notebook, and every lesson in the notebook has an exercise. So anyway, this was one example, and we'll have some more in the future interludes. So this is Craig Hain, aka Dr. Dell, signing off, and I will talk to you in the next interlude. Bye-bye.